In 3, 2, 1. And again. And again. So that's pretty good, eh? I was studying for one of my exams, and we came across one of these phenomena where you can see sparks of light from these Winto green lifesavers. I thought it was rather interesting, so I thought together we could go ahead and explore what's going on. Okay, so what's happening here? Okay, so we have our lifesaver, right? And as a whole, this is completely neutral. But when we shatter this lightsaber, by chance, there's going to be some areas of it. So it's like, let's shatter into some pieces. We're crushing this within our pliers. Okay, and we're shattering it, and we're shattering it, and shattering it, right? It falls into a bunch of tiny little pieces. By chance, there's going to be some pieces that are going to have positive charges, are going to be slightly positive. And then there's going to be some pieces that are going to have slight negative charges on the whole. Just by the random distribution of electrons throughout the entire lifesaver, there's going to be some that are going to be positive, some that are going to be negative. Okay. So then what happens to it? So as these pieces fall apart, you're going to have like one piece here, I kind of want one piece there, one piece here. It's not supposed to be a circle. One piece here. Okay, let's say this one's negative, that one's negative, this one's going to be positive, this one's going to be positive. Okay, and similar to when you have a static charge in yourself, like let's say you rub your feet on the carpet and then you touch something metal, you're going to see a little spark. You're going to have a bunch of electrons flowing through the air to try and neutralize them. They don't like having a large surplus of one charge over another. So this piece here, it has a surplus of electrons. This one's missing some electrons. So what the electrons are actually going to do is they're going to actually try and jump over to the other piece. This is happening in an instant, right? As soon as you shatter it, there's going to be some that are positive, some that are negative. It's going to try and jump over. While it's jumping over from our positive to our negative, it's going to be passing through a bunch of nitrogen. That's what air is, right? Air is like almost 80% nitrogen. It's mostly nitrogen. This nitrogen is going to be energized from all of these electrons trying to flow through the air. And then that nitrogen, now it's full of all this energy, it's going to try to release it. And it's going to release all of this energy. It's going to, maybe we should do like green. It's going to release all of this energy. In terms of UV radiation. Okay, so now we have UV radiation spilling throughout this entire environment, right? We have all this UV radiation coming up. Now that's what's special about these particular lifesavers, is that they have a compound in them called, let's do it in black. These Winto green lifesavers have a compound called methyl salicylate. And if you're curious, it looks like this. So that's what this is the compound inside the Winto green lifesaver that gives it the minty flavor. This is the same stuff that you find in like Listerine, and you can find it in some other like topical medicines. It has a really like strong cooling effect. So it can help with some joint pain and muscle aches and stuff like that, or as an antiseptic, like Listerine, and is exactly what makes this stuff taste minty. Now this methyl salicylate has this interesting feature where if you have UV radiation coming in, we're going to have visible light coming out. And this is the process called fluorescence. So like if you ever go to like glow bowling or something like that, you have all those UV lights and like all your white clothes fluoresce. You have glow in the dark is the same type of process. You're taking this high energy UV radiation. It's absorbed within this molecule and emits this blue light. So that's the blue light that we're seeing. When we shatter all of these lightsavers, the blue light is not the electrons flowing trying to neutralize themselves, but it's actually the lightsaver itself fluorescing. And we also have these other lightsabers. Because you go to other websites, right? You try to look this up. If you look up Winto green, like this is the first thing that comes up is this effect. Pretty popular experiment. And they say, some websites, they say, oh yeah, this can happen with some other chemical compounds, right? You may be able to see this effect on with a few other candies and stuff like that. But it's important to note that you need this compound here. You need something that's going to be able to accept this UV radiation and emit it as visible light. So if we have something like peppermint flavor, we shouldn't be able to see this effect, and we're going to go verify that. We're going to crush a few of these as well. Okay, so let's go back to our cam. And 3, 2, 1. And again. And again. So that's pretty good, eh? Like you can see that pretty clearly. And each time you're doing that, there's some unequal charge between different of these pieces, right? This piece might be this piece might be positive, this piece might be negative. So the electrons are going to jump from here to here, exciting the nitrogen, which is going to release UV, exciting the chemicals inside of this piece, and it's going to fluoresce blue. Neat instinct. Okay, so we've seen that quite a few times. Now, if we're going to take some lightsaber that's visibly identical, like they taste a little bit different, but visibly identical, right? Could you tell the difference between these two? Like, I don't think so. Okay, so this is our I think this is our peppermint. And if we load this up and we're trying to smash this, okay, we're going to see if we can get the same kind of fluorescence. In 3, 2, 1. Nothing. 3, 2, 1. Oh, it's tougher. Nothing. Nothing. All right. And again, that's because it's lacking this one compound inside of the candy, this methyl salicylate. So you can't, there's nothing to fluoresce. There's nothing to absorb that UV radiation and emit it as blue light. So all of this to kind of ask yourselves, like, why should we care about this at all? Why do we care that why do we care that when you break up this this lightsaber into all its pieces, we have some random distribution. It's very likely that some parts will be more negative and some will be more positive. That the electrons are going to jump over to try and become neutral to balance themselves out. There's going to be some emission of UV radiation, and then that UV radiation is going to fluoresce through methyl salicylate. Why do we care? And the answer is like, we don't really need to care, per se. Like, this is not something that's directly going to affect you in any real way. It's just kind of cool. It's kind of cool to take something like this and to smash it. You could have two identical lightsabers, and one you smash, and one you smash both of them, and one of them glows blue and one doesn't. It's like, well, why is that? And it's fun to kind of jump into it and figure out why, and to understand all of the components that are going on. The characteristics, we didn't even get into that, all the characteristics of the methyl salicylic that allows it to take that UV radiation and emit it as visible light. Like, what's going on there? It's fun to kind of dive deep into it and to appreciate it on a whole other level instead of just some cool blue light. Yeah, and so that's pretty much it. That was my science portion. I had spent. That's it. So hopefully I can be a vessel to convey some of these ideas and some of these cool facts. That's it. Thank you. Okay, now I can go read through the chat.